Okay, this is the mole volume practice tonight. So we've got 2 moles of nitrogen gas. So for every 2 moles of nitrogen gas, N2, there is a volume of 300 centimeters cubed. And we know if we only had 1 mole, how much space would that take up? So we got to divide by 2 here, divide by 2 here, and that is 150 centimeters cubed. I'm going to draw a particle picture for the first one. So let's just draw a particle picture for this 2 moles of N2. So that would look like 1, 2. And then the 1 mole would be half the space, but the important part is that the circle takes up the amount of space. They're moving in opposite directions. They're moving in random directions. There'd obviously be more than 1 or 2 particles in here. So 1 mole, remember, means that we have 6 times 10 to the 23rd particles. And this would be 12 times 10 to the 23rd particles. So the balloon here just gives us an idea of how this works. Okay, and then let's move to number 2. We've got a 10 liter balloon that contains 0.75 moles of oxygen gas. So for every 10 liters of space, there is 0.75 moles of H2 gas. And then if we have 12.5 liters, well, this would be times 1.25 times 1.25 is, well, we know that we've got 0.75 is the 1 part. And then a quarter of 0.75, well, half of 0.75 would be 0.3875 is a half. And then a quarter of that would be about I made this way too hard. 1.9-ish. So let's just call it 0.2. So this would be 0.95 moles of H2. And then again, if we're drawing a picture, now we're not going up as much. We got 10 liters and it occupies 0.75 moles. So let's just call that 3 particles. And the volume doesn't go up very much. It only goes up by 1.25. And so we'd put 4 molecules in there, and the balloon's a little bit bigger. Okay, and then we've got 2 moles of hydrogen gas are added to 3 moles in a 200 centimeter cubed balloon. So for every 2 moles, there is 2,000 centimeters cubed, and the balloon is going to expand because now we got 5 moles in here. So this is going to be times 2.5 times 2.5. And you can probably guess that since this is a 2 and this is a 2, then when this becomes 5, this becomes 5,000 centimeters cubed. So we've got 2.5 times as much. So that means that the balloon starts there and it gets 2.5 times bigger, so maybe we go there. 2 moles, let's just put 2 in there, and then 5 moles. We're going to try to get them evenly spaced. They're moving in random directions. A 6 mole balloon with 1.5 moles of O2 gas is deflated. Okay, so now we're going down. So now we got a 6 liter balloon. Contains, let's say, 1.5 moles of O2, and then it goes down to 4.5 liters. So this is times 4.5 over 6, which is 0.75. So 4.5 over 6, half of 6, just in case you wonder how I do that, half of 6 would be 3. So if this went down to 3, this would be times a half. 4.5 is in between 3 and 6, so this is times 0.75. So 1.5 times 3/4. Well, half of that would be 0.75, right? Half of 1.5 would be 0.75. And then we're going to add another quarter in because this is 0.75. So half of this would be 0.375. So we got 1.025. So about 1-ish. Oh, no, wait, that's wrong. 1.125, sorry. Moles of O2. So again, it starts with 1.5 moles. So let's just call that 4. And then it goes down by about a quarter. And we'll show that they're moving. And that's it. Okay, I hope you have a great night. Talk to you tomorrow.